So everyone, thank you again for coming out to the developer meetup. I know there's some beautiful Boston August weather. Hopefully everyone's going to get their suntan on after this. But I'm Nicholai. I run a team of financial services and healthcare engineers at InterSystems. So I've been here for 8 years. And today I'm going to talk about not healthcare. So if you're not a healthcare person, don't worry about it. What I'm going to talk about is financial document analysis. So who has ever tried to comb through thousands of pages of documents before to find one number or one chart? A few people, all right? It may be in school as a project. Control F only gets you so far. So I'm going to talk about that, how you can do it, and how you can use InterSystems software or any other vector database to actually power this in the background. So I am going to plug InterSystems software at the end, but we will talk about mostly open source stuff here today. Friendly disclaimer, and a little bit about me. Studied computer science, machine learning, information systems, and marketing. If it sounds like a lot, it was. I didn't sleep. I still don't sleep. But experience in emotion detection systems. So if you're ever scrolling Instagram, I'm sorry, the reason they know you're happy or sad, your likes or dislikes. We helped to invent that. Built some LLMs for clinical research in healthcare. And on Hugging Face, if you find me, we have some healthcare AI models we published a while ago. Some of the experience, just to prove to everyone that I know a little bit of what I'm talking about. On the left, some of my AI models get 1,000 to 2,000 downloads a month on Hugging Face. On the right, I actually play some men's league hockey for fun. And as you can see over here, I'm very slow, 3 kilometers a second. So I'm pretty sure you can walk faster than that. So, all right, let me set the stage. Enough about me. So the talk, right? Why are we here? If you're in financial services, you program or build for financial services. Lots of investments have CSV-like data. You can query it, you can download it. But for a whole universe of alternative investments, they don't. There's actually PDF files of, I won't call it crap, but less optimal data that you got to comb through. And they actually have teams of analysts. If you look at the large asset managers, they have teams of analysts that get paid very highly to go through all this, read it all day. They sometimes send them across the world to write these reports to get answers, right? Should I invest or disinvest or hold my position, right? So first thing you might think is, let's just ask ChatGPT. Like, let's see if ChatGPT knows some of this information. And unfortunately, it doesn't really know everything yet. It hallucinates a lot of the information, even if it's well written down in PDFs or documents. Now, if you use Perplexity or others, these are getting better, but it's still not great. And the classical AI search implementation, which is funny to say because a RAG pattern is really only about a year old, they're still kind of broken and a little slow. So imagine this. Your job is to figure out whether you should invest in a country, right? And what does that mean? Maybe I'm going to buy a bond. Maybe I'm going to sell a bond. And so if you like the movie Borat, let's look at Kazakhstan, right? So I've got 4 documents. 4 documents. There are thousands of documents on Kazakhstan. I've got 4. And look at how many pages there are. This is the public library, so you can Google for these. BTI, International Monetary Fund, Atomic Report, Kazakhstan has uranium, World Bank reports, you name it. Hundreds and hundreds of pages I've got to search through. And so you'll see how we can do that efficiently today. But that's not fun, right? How am I going to be a good research analyst if what I want to find is on page 63, 2, 5, and 112 for each of these reports? Well, it's going to take me a long time. I probably also have my own reports I've written for years and years and years. That's my proprietary sources from my own proprietary data. So one day your portfolio manager says, hey, explain Kazakhstan's balance of payments and the reason for their current account change. And so you got to spend a day here at Document Mountain. So that's not fun. So the goal, and you'll see this in a demo, you'll see how we could do this, see how you can implement this, is to actually answer with supporting evidence from a huge corpus of documents quickly and get a good answer with AI. So we're not expecting AI to know this. We're not expecting AI systems to have implemented this. But what we're going to do is intelligently take pictures of this document using AI models, vectorize them, and then store them. So this is the end goal. And so how did we get here? Well, like I said, the first thing is we just asked ChatGPT, which is sort of like the hopeful oracle. And that's what I did. So on the right, I said, tell me about Kazakhstan's social programs. and it started talking about a graph of COVID. So not really relevant. This is, yes, the latest version of ChatGPT. I'm a little bit of a procrastinator, so this was done this week. Not great, and it sort of felt like ChatGPT is just making up an answer. I didn't test the other AI models just because I didn't subscribe to them. And so the next step you might do is you might take a bunch of these documents and put them in what I call the shredder. So who here is familiar with a RAG pattern? All right, that's a lot of people. So for those who don't know, it means chunking all of your data, embedding them, which is converting that data to numerical meaning, and then storing it in a database, which you can then do a similarity search against. So that's great and all, but there is a problem, is that at the end of the day, you have to do a lot of steps to get a high quality output. And so like this sewage pipe here on the right, you have to do a lot of things just to get okay answers. So you're really the state-of-the-art RAG pipeline would be you run OCR, try and figure out what pictures are to text, detect the layout, maybe re-rank that text position with layout. You then want to build a reading order, recaption those documents, your charts, chunk your text. I'm going to read all these. Generate your embeddings, update your vector database, re-rank those texts, and then do context engineering when you finally ask AI. So who thinks that's too many steps? It's all right if you don't. And who thinks that's going to be really, really accurate? Yeah, it's just okay. So the reason why this isn't that accurate is because if you look at this example here on the left, this is Palantir's investor update. And my US commercial revenue is up 71% year over year. So I might be the analyst or the portfolio manager saying, do I invest or disinvest or hold course for Palantir? Now, if I chunk that data, it comes out what you look like on the right. What does 71% mean on the left? Does everyone know what 71% means on the left? Everyone, yeah, raise your hands. Okay. Does everyone know what it means on the right? No. So there's got to be a better way. And the result of this sort of best benchmark is about 60 to 70%. So it's like a C minus student. That's it. C minus student. It's not great. It's better than nothing. And if you need a quick answer, maybe you're going to get a good answer. And would you really trust someone to be your financial analyst or put your money or your 401k or retirement or your secret crypto stash, right? Probably not. So this is what it looks like visually on the bottom. You take a document, you identify the different layouts, you convert that with OCR, you caption, you chunk, and then you embed it with a special type of model, the embedding model, and store it for retrieval. So that's really slow on the left. The retrieval is pretty fast. So what if we could just feed that document at these LLMs that can now do visual analysis? Well, they work pretty well. So this is step one, right? If you've ever used ChatGPT or others and you talk to it, right? You start talking to ChatGPT. You take a screenshot of something, you take a picture and you go, what is this plant? Or you upload a financial PDF. The result is it's pretty good. It gives you really, really good results, right? So I get a great answer for this question on the right. What the actual answer is and the question I answered, well, it doesn't really matter. But the issue with this is it's slow and the cost is very expensive. So if you're going to throw 400 pages of documents, let ChatGPT or O3 analyze, you're going to be spending thousands of dollars a month. Now, depending how much money you are investing, that might be worth it. But there's a better, cheaper way. It's kind of like asking a team of experts to read every page for every question. So there is a better way. And it's what if we could instead do RAG across visual meaning? So the same way you and I see things, what if we could do search and RAG across the visual way I look at the page? And so there's a really interesting breakthrough, which is there's a series of models where they take one of these vision LLMs and they chop off the end. Literally, they just chop it off. And that creates an embedding of the image. So you take this image encoding LLM, so Quen series, think ChatGPT 4.0. Quite literally, these researchers chopped off the end, and you can download these and run these yourself. And they take those embeddings, and out comes a series of embeddings over here. that you can then do similarity against. So problem almost solved. Embedding is fast, queries are fast. It only takes about a quarter second to half a second for each page. And the query is the same speed because it's just that same length of numerical data you're querying against. So this is one of the recent breakthroughs. The other one is that when you get these image models, I don't know if you can see on screen, we actually divide the page up, down, left, right into patches. And so since we have all these patches per page, what we get out of it are multiple vectors. So if you have 16 patches, you get 16 vectors. But those relate to each other. They don't relate to other information. So the smart people at Google figured out a way to transform that into a flat vector that you can stuff into any vector database. And so in the demo I'll show you in a moment, we use this algorithm Movera to flatten multi-vectors to a single vector, and you can then put that into any vector database, or put it into one of the fastest vector databases like InterSystems has. And this is really important because you can use HNSW index. So this is think of it like a shortcut to searching. And you can use acorn1, which is a shortcut to searching when you know you only have a certain where clause in your query. And the result is that you kind of get this two-flow architecture where if you want to load data into your vector store, you take a document, you embed all of those images, each page is an image, you get that multi-vector out, you transform that to a flat vector, and you store it. In this case, we'll be storing it in InterSystems Iris. Then when you search, you don't need an image, you don't need a query. You don't need an image, you just need a query. So that same image model that we chopped off the end to begin with, you can give your text or question to it, and it can now compare text questions or basically any text content to physical as seen content on the page. And the way this works is really interesting. I don't know the internals of how the language model is actually working, but the cool thing is sometimes you just chop off the end and it kind of works. And you can then take those results and then share your query to a VLM like GPT-4o. And then you've now gotten your benchmark for document search and document embeddings up from that 62% to about 95 or 96% when tested. So let me show you this in a live demo, what this looks like. So I've got a little UI here, and I've loaded up those 5 Kazakhstan pages from before. And just to show you what's going on here, there's really 3 steps. I've got a collection up here on the top left, which is a iris vector collection. I have a search bar here and a few data points from my collection in the background. This is running in the cloud on Iris SQL, sponsored by AWS. AWS is actually running the hardware and software behind this. So if I want to ask a question, maybe I want to just find something in a document. Maybe I remember, hey, I remember reading through these 200 documents. I want to find about those social programs in Kazakhstan. And since we've flattened this to a regular vector, you can imagine we've got 250 pages in this collection. If I did a Control F just on regular text, it will be slower than the search I'm about to do. Here we go. So the search time took 170 milliseconds, partially because Iris vector database is that fast. But also because we've done so much interesting work on that vector, a lot of complex math work that, it was a lot to figure out, but it's not too much to actually implement. And if we look, we'll see, hey, here's that graph I cared about, right? Here's my graph I cared about, my key social assistance programs, right? So the visual encoding and the way we think about it, which is I thought this was a cool graph, I can now search in plain text against my whole corpus of documents. So the next step, past searching, isn't just getting the results back, it's actually doing something with it. So I'm going to turn on this full Q&A mode, which is then going to feed this document to an LLM. So I could say graph of Kazakhstan social programs, but who knows what it's going to say. I could ask a question about it. And I'm going to enable this on the left, which is re-ranking, which is just going to reorder the results with that same AI model. So again, the results come back really quick. The AI model is now going to run, same AI model, and coming back, just like every other AI model, we should see a streamed answer here. And it's probably a little small here, but let me just zoom in. So we can see that it's actually parsing all the information from that graph. The same thing I wanted to know about. If my PM calls me at 2 in the morning and say, hey, I just got off with the minister from Kazakhstan. He said they're going to cut spending to social programs. What was the spending of the social programs? I now can go just ask my collection and get that result back very quickly. And so this is great, but we also have supporting evidence. So we can see this is what the LLM used in the background. These other two documents were also passed. You know, they might not just have a chart, it might have other information about it. And if I wanted to see all the search results, I can see here at the bottom. So this may seem easy, but it is sort of a breakthrough, particularly in how good these encodings are. And if you want to see how good these models perform, there is, and I'll have to go back to my slides here. There's actually a benchmark called VDORE, V-I-D-O-R-E, which is Visual Document Object Retrieval. And basically that will, you can see how well the models do. Up until a few months ago, the visual document retrieval, ChatGPT gets about 66 to 70%. These new models, particularly one from NVIDIA, gets 90 to 95%. Meaning that if I'm going to ask visual Q&A against a document, I don't have to go search through thousands of collections. And since we've flattened that to a different dimension of vector space, it means that it's going to be fast from one document to hundreds of thousands of documents. So all of this, we've made open source. So we have, if you want to see ISC and Mitchko / Iris document search, you can take that and it uses Iris vector search as the vector engine as in the background. You will need a little bit of GPU power on your end. We do the embeddings of this sort of chopped in half model locally. But you feel free to change the code, fork it, do whatever you want. Ask ChatGPT how to run it on your system or quantize it. And then we use Cloud Vector SQL in the background. So we have a trial of Iris. We give about, I think it's $300, but if that's not the right number, it could be $250 or some other amount of free credit. So if you want to just run this for your own reason, you know, sometimes you could upload pictures if you want. I want to find the picture of me standing in front of, you know, document mounting. You know, that's the sort of query you can do as well. And the results come back incredibly quickly. And you can deploy a Cloud SQL trial instance, and it will shut down when you run out of money, but it lasts pretty long. So kind of what's going on, you know, how we can make this so fast, that 0.19 seconds, 0.17 seconds, is that Iris is actually a key value database in the background. So when we make a query and we store a vector data type down here, it's actually in a key value pair, which is the fastest mathematical way to store data to and from disk in a logical flat file. We've done this the whole time for Iris and our previous versions of our data platform. But this is the reason why we're so fast. Just thought it was a cool thing, so I put the slide in here. And we're always getting faster. So if you're wondering if your Cloud SQL is going to get slower as you put more documents, with each release over release, we get better. And we do billions of data point references, which is why we find Iris in systems like largest medical records in the world, as well as mapping the galaxy and financial services transactions. So with that, here's a few references. If you want to figure out, and feel free to take a picture of this if you want to look up the papers. If you want to figure out the source of that embedding model, it stemmed from this paper, which is Cole Poly, efficient document retrievals with vision language models. Again, these are the guys who figured out, hey, let's just chop off the end. The second one is Movera, and I have an implementation that's decently optimized on that GitHub if you want it, which is multi-vector retrieval via fixed dimensional encodings, which basically transforms the vector space. And the actual model I use here is a fine-tuned version of Colnomic from the top one. So the one you see here, just fine-tuned for fun. But Colnomic, 7 billion and 3 billion, you can run them on your laptop to actually do that query embedding.